in Vietnam. Here's Don with a full fresh bag of dicks ready to rock and roll. We're going to learn a little bit of crap today. And hi, Chuck. Hope everything's going well for you, brother. I know work is hard and you got a lot of stuff on your plate. And you got a crazy woman trying to drive you nuts on a daily basis. So more power to you, brother. More power to you. I'm just kidding. So anyways, we're going to kind of look over a couple things. I sent an email this morning where we were talking about, I was talking about, you guys were just reading. But anyways, I was talking about reducing some of the, I guess, technical issues that come in with trying to learn Fusion 360. I've been using it for years. I've been doing AutoCAD and using Autodesk products and other 3D modeling, SolidWorks, and other stuff for years. And so for me, it just seems like a no-brainer. You just go in there and start working with it. But, I was sitting down with Bridget and I was kind of showing her how Fusion 360 works, and I got that glazed look in her eyes that she gets sometimes when she asks me technical questions and I have to explain it. And, I suddenly realized that maybe Fusion 360 isn't the easiest software on the planet to use. So based off of that, I did some research and stuff, and I paid for a couple different softwares, and I'll be talking to you guys pretty shortly about our plans and why I'm doing this on my own. We bought a CNC. It won't be here for a few more weeks, and so we're going to be building a business for Bridget so that she can do crafty crap and sell it on the internet and hopefully make enough money that I can retire. That sounds really good. A margarita in one hand, a big fat doobie in the other hand. Yeah. Bridget doing all the work. Yeah, that's life. Hey, Chuck, maybe you can learn from me. Anyways, so at the end of the day, I found that using some of the software that really is out there that's designed for wood and plastics and things like that really work well for doing the type of machining you guys are doing, which is basically 2.5 axis stuff, right? You're not doing major 3D stuff, and Fusion 360 is really designed for high-end manufacturing and design work. And so it can be a little bit daunting because the software is not necessarily designed for the novice nor somebody who's doing just basic simple stuff. People are successful using it, people in woodworking and foam cutting and things like that, but a lot of these people, if you really get to know them, are probably guys like me who already have experience doing that kind of stuff, and they figured out how to make it work for their business using Fusion 360 that they already knew. So starting from the ground up, you guys are relatively new to this whole idea of taking stuff off of your screen, putting it into a control, and having some machine take your ideas and turn them into something real. It's been happening for years. It's not something new, but it is new to you, and so we're going to we may need to take a little step back. I've been kind of thinking about it and worried about it because there's just so much to learn already. Adding Fusion 360 right now, I think, would be more of a hindrance to your business and slow you down a little bit. As far as being able to grow past having to depend on so many people to do stuff for you. As you've probably already figured out by now, depending on other people has its advantages, but it also has a high level of disadvantage. And yeah, we'll just leave it at that. So even depending on me, sometimes may not be as reliable as you'd hope, right? So it's better that you have really simple tools, I think, that get you where you need to go so that you can be less dependent on Rob, on me, on whatever it is. And there's just really good opportunities to really do self-learning. There's a lot of stuff out there about Fusion 360, but a lot of it's so piecemeal. It's hard to really establish exactly what pieces fit to what, right? So you got the software, and you got the CNC control, but the most important part is the tools, right? How does understanding the tooling and everything, we're not going to get into that today. We're just going to talk about software. As you can see on the screen right now, you can see your software that you guys see on your machine. I would hope it's exactly the same. It's the same one I made for you. So, But in any case, typical setup. I went in and set my work offsets. You can see them over here. There's a work offset set, and I've got tool 3 in there, and I've told it that it's 10 inches long, so that's why this is the tool right here. You can see that it looks kind of similar to what you already see anyways. But in any case, the benefit of using a simplified program is that it's really designed for people who are decent at doing art. And you can tell I'm kind of new to this whole YouTubing thing. But anyways, but it's more geared for people who do art and turn that art into creative things that they build through CNCs, right? And so this you're obviously used to. You can see how it started. It's actually a working program. Everything you see here on the right was written in CarveCo, Maker Plus, the software that I was mentioning in there. You can see that the program has these long numbers in there. That's because the program itself is metric. That's because the parts, the actual files that Rob sent were actually metric. And so it's easier just to go ahead and leave it metric, program it metric, and then convert it, have the machine convert it into inch. So you can see over here, everything's in inch, just like you normally see it. You set all your work offsets and tool offsets and everything else in inch. But the program just runs in metric. It's really not that big a deal because you've already done everything on the front end of your program, so you already know what size it is. There are some challenges for you to learn, understand that, it's metric, but I'll be talking about that in a second about how to understand how to convert metric to inch and vice versa so that you can kind of understand that. It's actually very easy math, even for TJ. So we can work on that in a second. So I'm going to go ahead and pause it because this part you guys know. I don't really need to discuss any of this stuff. But this is CarveCo. So CarveCo has been around for a while. It's software that's designed in Britain, and they talk funny in their little training videos, but they're really helpful. The videos are very good. They have several videos on the web. They have several on their website that you can watch. It has a lot of neat features. It's got a lot of buttons, but most of the stuff in here, for now, you're just going to be importing somebody else's solids. And as you can see right here, just like in the email, I told you I used 2, 3, 10, and 11 in that little picture that was in there that Rob said that was showing the basic layout for each file. And these were solids. And I imported them in to CarveCo. And then I basically said, hey, CarveCo, let's do some stuff to make this thing cut, right? And so that's kind of where we're at. So I'll show you how to do that in a little bit, but it's used some different things up here, but these are called what they call a relief, right? So a carve is where I'm actually carving into the material. So I'm actually this is above the material, and so this is what they call a relief. So I'm relieving the material around my part. Whereas with carving, I'm actually taking the material out of the taking a cut out of the material to make it so that if I was doing a sign or whatever, the material in Z would actually be down here below it, right? And so you can see that right now these parts are your parts and they're actually above it, right? Now never mind this, don't worry about that. It doesn't, just because they look hollow doesn't mean they are, but that's just how it brings it into saved memory. And so basically I've been was able to create your files, and this is kind of just a little step to actually simulate it, so it's going to show me what it's going to cut like. But I guess I better actually do it right, so hang on one second. Let me close that and give me a little error, but that's fine. It's me, it's a problem. All right, so I'm reset. Now I can go back in and actually simulate that, so I think. There we go. So you can see here, this is just a rough out of it. This is the first roughing stage. Now it does a little different than what you're used to seeing, but it's similar. So, but here it is, and then it's basically, that's what it's done. It's finished cutting the whole thing. So let me go ahead and reset it the right way. And now we can actually see it. So that's what it's basically doing. So when the first step what it first does is it actually just clears off that material. Now the parts that most of the parts that are in those STL files are not 10 inches deep. In fact, they're not even 5 inches deep. And so this first half is just cutting off a bunch of loose foam. It's just wasted material. You could have gotten away with just getting 5-inch deep foam, which would have worked perfect. But you can see here where it's just going to go back and just going back and forth, what they call a raster, and it goes down to a Z point, and then it just goes left and right and Y. And this is your Y-axis here. This is your X-axis, just like your machine. You can see where I have 0 set over here, just like you would on your machine. And it finishes it up. You can see the little tool over there. And it gets done with this, it's going to move to the next stage, which is actually below that. Now you can see where it's down. This would be the table. It's not cutting the table. It's actually just a little bit above it, which is what you want. That way you're not carving your table up in little tiny pieces and making a mess. But you can see here where now it's actually cutting around those parts. All right. So it's only 5 inches deep, so it's not the 10-inch deep issue that you had before. And so it's going to continue to do that as it goes through, and it just cuts them all out. And then after it gets done with that, then it comes back and it actually finishes out those parts and carves them out and makes them look like tiki instead of just big giant lumps of foam. So that's it. I'm going to go ahead and stop it. And that's basically it. So this works fine. The system itself, the software, it takes a little getting used to, just like any software will. But it's very simple. There's pictures, and it doesn't ask you a whole ton of questions. So basically, I'm going to probably stop this so we can keep these recordings a little shorter, and then I'll set up do a second video where I'm actually going to walk through the steps. A brand new file, bring it in, show you the steps of doing that, and how you can actually pick the PlanetCNC post processor, which this software has. It has the actual post processor for the machine. And it outputs the code properly for the PlanetCNC system. So I hope some of this is starting to make sense. I hope that what I'm going to show you is enough to get you started. Of course, I'll probably do some more videos as I learn more and more about the software and really understand exactly how it's all the other features. There's a lot to it. In the software, you can actually do your own artwork in here. You can import files, vector images, and then turn those into 3D release on your own. As you guys decide, maybe start moving your business up a little bit and getting away from, using Rob's files and start dealing directly with customers and creating your own files. So there's a lot to learn, but at this point right now, getting you to a point where you can actually take his 3D solids and turn them into programs on your own, so that you don't have to go back and edit them and deal with waiting on him and all that kind of stuff. All you need him to do is send you the 3D solid models, and you guys can figure out the rest of it by using a software like this. Pretty simple. All right, so we'll catch you in the next video.